somewhat similar to what we've done. If we worked on the tangent cube, if you expect the integral of the secant cube, you were absolutely right. Okay, we know that the tangent and the secant go hand in hand. So what we're going to do here, let me see. Well, to save you the agony of trying, because you can spend about an hour for just trying a different strategy, I can tell you that in this case we're going to use integration by parts. Use IBP. Okay? So, what I'm going to do, I'm going to break the secant as secant times secant squared. Why is that? Because the secant squared d theta is a convenient differential. So we're going to write that the secant cube is the secant times the secant squared d theta, and I'm going to split, here's my u and here's my dv. So let's write it here. U equals secant theta, okay, and dv equals secant squared of theta d theta. Therefore du equals, what is the derivative of the secant? Secant times tangent. And guys, in your test, you forgot to add d theta at the end or dx at the end, because you're looking at du, right? And if dv is the secant squared, what is the antiderivative of the secant squared? All right. So, and this is I, the integral. So now we're going to say that I equals uv. uv is the secant times the tangent minus the integral of v du, right? V is the tangent and du is the secant times the tangent. So what we're going to do, we're going to leave, well, there's nothing here to do, but here we go again. We have minus the integral of the tangent squared times the secant. Okay? Once again, I'm going to substitute the tangent squared with the secant squared minus 1. We've seen that before, right? So we'll have the secant times the tangent minus the integral of the secant squared minus 1 times the secant. Here we need to exercise some patience, and we have the secant times the tangent, and we'll clear the parentheses. So we end up having the secant cube of theta, and then negative or minus double negative here gives us plus the integral, oh, I'm sorry, this is d theta, plus the integral of the secant d theta. Okay? Couple of observations. What is this? This is the integral we started with. This is the integral of secant cube, right? So this is I. Remember that? This is the integral of the secant. Did we just solve it? This was the natural log of the absolute value of the secant plus the tangent. Because I still have the integral here, I'm going to leave the c alone right now. I know that there is a c, but I leave it till I solve the final integral. Now add the two integrals. I have I equals something minus I plus something else. Then I'm going to say that 2I equals the secant tangent plus the natural log. Tell you what, here I can put the c. We'll call it c1. Okay? And here comes the final solution here. The integral will be 1/2 the secant times the tangent plus 1/2 the natural log of the secant plus the tangent plus c, where c equals 1/2 of c1. So this is, I'm not sure if you're going to use it as a reference for the integral of secant cube, but this is the solution for the secant cube. Okay? So you can see it's not a trivial integral, but it's a powerful tool nevertheless.